Welcome to the SMS Fundamentals presentation. These lessons will provide you with a general understanding of the principles of a safety management system, SMS. It will also provide you with an understanding of the components, elements, and core processes that comprise a functional SMS. Each organization must determine its safety needs and scale its SMS to meet those needs. Specifically, we will answer the questions, why is the FAA involved in SMS? We will discuss both the business case and the safety case. What are the SMS fundamentals? We will provide a high-level overview of the SMS fundamentals before drilling down into each component, element, and process. We start by covering the primary SMS components, which are policy, safety risk management, safety assurance, and safety promotion. Finally, we'll do a high-level overview of the SMS guidance, tools, and implementation, and how SMS implementation is being done in the United States. You've probably heard a lot of rumors about SMS. In our experience, most of what you have heard is wrong. This presentation will clarify most, if not all, of those misconceptions. Let's first explain what SMS is not. SMS is not a substitute for compliance. This is not a system that is meant to take the place of or usurp any of the federal regulations or policies. As a matter of fact, the SMS calls for regulatory compliance to be woven into overall safety management structure. SMS is not a substitute for oversight. There will always be a need to ensure that a baseline of safety exists in accordance with federal policies and regulations. In other words, the oversight component will always be there, but will be an independent assurance of performance and effectiveness of the operator's management system. SMS is not a replacement for system safety. Many people are aware of system safety in that it focused on safety risk management and intervention. SMS takes those components of system safety and adds to them by including assurances that those safety components are and remain effective. SMS adds an accountability aspect as well as a focus on management functions emphasized in early system safety efforts. SMS is not a requirement for a new department. An aviation safety management system, SMS, is an integrated system that is found within the entire organization and has many applications at different levels of the company. It doesn't require another kingdom to be built within an organization. SMS is a decision-making tool for all levels of management to consider and act upon. SMS can be scalable to fit any organization. Let's compare SMS, the Air Transportation Oversight System, ATOS, the Safety Assurance System, SAS, National Work Program Guidelines, NPG, and a Quality Management System, QMS. Pay particular attention to the last two letters of each acronym. SMS is a management system. ATOS NPG is the FAA's oversight system. Let's examine the similarities and differences between SMS, the Air Transportation Oversight System, ATOS, the Safety Assurance System, SAS, and a Quality Management System, QMS. ATOS NPG is the FAA's oversight system. ATOS uses a risk assessment process to determine the safety assurance objectives. Design assessments, SAIs, are used to determine if the operator system is designed well enough to meet regulatory requirements and handle the operator's own risk factors. Performance assessment, EPIs, are used to determine if the operator is performing well enough to meet the safety objectives designed into their system. SAS, or the Safety Assurance System, is the FAA's future state of our system-based oversight and will be expanded to include 14 CFR Parts 121, 135, and 145. Finally, we have QMS, or Quality Management System. How do SMS and QMS relate? They both use the same principles, however they use them for different reasons. QMS is concerned with a quality product or service, while an SMS's objective is a safe product or service. Both are management driven. The United States has an enviable aviation safety record, so why mess with it? What do we understand about U.S. aviation safety? Where have we been? What have our collective efforts yielded? All in all, our record is a good one. Looking at this graph, you can see that in spite of a large increase in accidents in the mid-30s, the accident rate has been steadily declining and remains at historically low rates. It's flatlined. It's been stated that aviation is the safest form of public transportation in the U.S. So why change? If things are going so good with our safety strategy, why change something that seems to work? For one thing, our air transportation growth is quickly outpacing our current safety approach. In simple terms, that means we do not have enough safety inspectors to maintain oversight at the current ratio. This concept was presented to the FAA's managers meeting in August 2009 by Malcolm Sparrow, professor of public management, Harvard Kennedy School of Government, and a frequently quoted expert in risk management. Inspectors in aviation industry's safety focus has been driven by the question, is it legal or is it illegal? This is regulation-based thinking, but simply looking to enforce minimum regulations does not answer the question, does it cause harm? This change in focus is the basis of SMS thinking. The circle on the left represents things that are regulatory, and if violated, those actions become non-compliant or illegal. The circle on the right represents things that are not regulatory, but can cause harm, such as a negative culture or departmental conflicts. The overlap in the middle are those things that are both regulatory and can cause harm, indicating where the FAA and the operator's resources have historically been spent to meet safety objectives. Another thing to point out is that regulations are made for everybody and for hazards that affect everybody. But there are harms that may be significant for one or a small number of operators, but not for all. SMS fills in the gaps through a safety risk management process. To understand safety management, we first have to have a good definition of what we expect from the term safety. Where do we find the definition of safety? In the years since the United States has been regulating the aviation industry, the term has not been officially defined. However, as we look back in history, we see a consistent relationship between concepts of risk and practical definitions of safety. So before we go further, I'd like to make sure we understand what is meant when we use the word safety. Using the dictionary term for safety, it means freedom from harm, injury, detriment, damage, or degradation. Although literally correct, it may not be a perfect definition of safety as we apply it to aviation. But it does introduce the basic fact that safety has something to do with harm. In a 1980 decision, the U.S. Supreme Court said that safe is not the equivalent of risk-free. If safe meant freedom from all possibility of harm, few human activities would meet the standard. So this points us in the direction where safety is defined in terms of degree of harm and how likely it is to occur. Jerome Lederer, who many consider the godfather of aviation safety, has considered the term risk management to be a more practical term when describing safety. This would be true because aviation itself exists in a very risk-intolerant environment, and it doesn't take much inattention to hazardous conditions or situations to bring about an unwarranted event. So now we're saying that safety is related to how well we're able to avoid serious harm. Going way back to the earliest days of aviation, even Wilbur Wright understood something about safety when he said, "Carelessness and overconfidence are more dangerous than deliberately accepting risk." In fact, if we think about the two components of risk, severity, how much harm, and likelihood, how likely are we to be harmed, we might say that the lower we can manage risk, the closer we come to a practical definition of safety. Thus, we can define safety in terms of the effectiveness of risk management, and we'll understand that risk management is one of the core processes of a safety management system. This is the ICAO definition of safety. There are a lot of words here, but if we follow the golden words, we should see the thread we just developed: reducing likelihood of harm, making decisions about the risk, acceptance, identifying hazards, things that can hurt us, and finally controlling or managing the risk. Now let's look at ICAO's definition of a safety management system. ICAO defines SMS as a systematic approach to managing safety. This refers to looking at systems and managing those systems. In other words, we don't want to look at just the pilot. We also want to look at pilot training, pilot checking, pilot manuals, chief pilots, operations managers, fleet managers, the entire system that supports the pilot. This same principle is then applied to all sectors of the service provider's operations. In summary, SMS is the application of business management practices to the management of safety. We have a definition of SMS, but what does SMS do for us? SMS is a system-based approach that has as its core objective to identify and control risk. It allows us to have greater confidence, assurance that risk is under control. The service provider institutes the controls, and the oversight authority verifies the controls are effective. It provides a uniform, formal method to comply with the rules, and it provides a method to evaluate an organization's safety management capability. As pointed out earlier with Dr. Sparrow's diagram, the SMS also helps control the effects of hazards that are beyond current regulations. System safety concepts have not changed, but have been incorporated into SMS. The first bullet shows a general description of system safety from which our oversight processes have evolved. The second bullet is traditionally where system safety efforts have been focused. An example of technical application might be the review and approval of a certificates holder's RVSM. 3 inspector technical specialties are required to be involved in that approval process. Systems thinking would additionally consider the interfaces between the technical experts, as well as the interfaces between the organization's procedures, manuals, workforce, etc. The third bullet applies SMS to the mix and evolves system safety principles to include management elements, specifically expectations and accountabilities. ICAO is a United Nations organization that issues international standards related to civil aviation. The FAA is not pursuing SMS because of the ICAO standards. The FAA is moving toward SMS because it is the right thing to do. Now, there was a lot of energy around the deadline for member states to be compliant with Annex 6 and what that means for the U.S. aviation industry. It's important to remember that the ICAO requirement applies to member states, not individual service providers. This is an extract of the key text. Notice the golden words. There are 2 requirements for the FAA in the ICAO standard. First, we need to develop an SMS rule. Second, we need a method to evaluate a service provider's SMS. The U.S. has filed a difference with ICAO. It's not an exemption or a get-out-of-jail-free card. It merely states that we do not comply with the ICAO standard now, but we intend to. Each ICAO member state must decide individually whether to allow us into their airspace while we are in non-compliance. Currently, the FAA has no procedure to approve or accept a service provider's SMS. That will come along with the issuance of a rule. Amendment 33 of Annex 6, Part 1 added more detail to the SMS requirement and a new date for compliance. Annex 6, Part 1 originally only referenced an SMS without further elaboration. Amendment 33 qualifies the SMS to include the components and elements contained in the ICAO SMS framework. We will discuss the SMS framework later in the presentation. Annex 6, Part 1 applies to only international commercial air transport. That would be Part 121 and 135 service providers authorized to conduct international operations. However, the FAA and most other states are working toward SMS rules for all air carriers, both domestic and international. Annex 6 also carries the same SMS requirements for authorized maintenance organizations, repair stations in the U.S. The FAA has been charged by Congress, Public Law 111-216, to develop an SMS rule by August 1st, 2012. ICAO Annex 6 Part 2 establishes the SMS standard for international general aviation, including aircraft operated under Title 14, Part 91, as defined by aircraft type and/or weight. Here the emphasis is on the service provider or operator to establish their own SMS based on their size and complexity. There is no FAA requirement here. Part 2 also includes some recommendations shown here. Now let's look at the big picture view of SMS as it pertains to ICAO and the FAA. We've been talking about ICAO's Annex 6, which is the ICAO standard requiring a state safety program and service providers' safety management system. So now that we know what is required, we turn to ICAO Document 9859, the Safety Management Manual, which contains the procedures for implementing a state program and the service provider's safety management system. Within aviation safety, there are two forms of SMS. The first SMS, which is our state safety program, is for our own AVS lines of business. This applies SMS to the FAA's own internal processes and is known as the AVS SMS or the internal SMS. There are several lines of business, for example, flight standards, AIR, aeromedical, ATO, etc. And each line of business will be implementing the AVS SMS in their own area of responsibility. Two orders provide the policies and procedures for the AVS SMS. The second SMS, the right-hand arrow, is the one we apply to our service providers in the form of an SMS rule and is called the external SMS. It is part of flight standards and is managed by the SMS Program Office, AFS 900. There's an order, advisory circular, and other developmental guidance available that we'll talk about more later. Finally, there is the service provider's SMS. The service provider's SMS manages their own risks and monitors their own risk controls. Let's examine the roles, responsibilities, and relationships between the FAA and our service providers. Each service provider has operational processes that are used to provide services to their customers. The FAA has oversight processes that we use to accomplish oversight. Currently, we use the NPG and ATOS. In the future, we will use the Safety Assurance System, SAS, which will include our own internal SMS processes. Traditionally, the FAA accomplished oversight by way of numerous direct inspections of the service provider's operational processes. In short, we have provided the service provider with safety assurance, or we're more like quality control of their operational processes, not really an oversight job. With an SMS, the service provider or operator will increase their role and responsibility for safety assurance by managing their own risk and monitoring their own risk controls through their own SMS. So what happens to our traditional oversight? Under SMS, the FAA provides oversight of the operator's SMS to assure ourselves and the traveling public that the operators are managing their own risk and monitoring their own controls. We will still do direct inspections of the operational processes. Remember, the trust but verify axiom, just not as much as under traditional methods. This also serves to validate the operator's safety management processes. This is a significant difference from traditional programs and regulatory obligations that the FAA requires and changes the relationship between the FAA and the service providers. We'll discuss the details of those relationships and how they interact and interface in the fundamentals section of this briefing. Next, we will be discussing the case for SMS and the safety fundamentals SMS represents. SMS is not an entity or a thing, nor will you find it on an organizational chart. It is an integrated way of doing business, managing safety, or more specifically, managing and controlling risk, much as an organization manages other critical business operational functions like finance, human resource, operations, etc. Often we hear that safety is number one at our company. But how does that really work? I would suggest that the true objective for a company is often to make money. Aviation companies are not in the business to manufacture safety or provide a safety service. Aviation companies are in the business to provide a product or service to create revenue, to continue to operate and grow. That is the way it's supposed to be. Aviation businesses, like other business, operate in a marketplace. The reality is that business exists to make a profit. Without the ability to make a profit, a company will not remain in business and will thus not be viable. Companies have a legal and regulatory obligation to remain viable. Companies also have a legal obligation under Public Law, Title 49, Section 44702, to provide service with the highest possible degree of safety in the public interest, and holds their management accountable for doing so. Therefore, making money and doing it safely are foundational to their business model and business decisions. An airline has an obligation to provide a service to the public. DOT only provides them with a certificate if they're providing a useful service that is in addition to their safety obligation, which is what we usually relate to. In total, companies have an obligation to provide a useful and safe product or service, and to do so while making money. Thus, since we exist in a risk-inherent environment, we must integrate safety, risk management, and risk controls into everything we do, whether it is to develop, modify, or maintain a product or deliver a service. Integrating safety into business decisions and making the case for integrated management is foundational to an SMS. Here we depict a balance between the resources the company applies toward production and its own internal protection, which has taken the form of quality control and quality assurance programs. Obviously, too many resources in either direction would not be good and could affect that thing we talked about earlier called company viability. Here are a few key points. Safety issues are the byproduct of activities related to production, service, delivery. They are always there. An analysis of an organization's resources and goals allows for a balanced and realistic allocation of resources between protection and production goals, which supports the needs of the organization. The normal course of delivering production creates safety issues that need to be managed. An organization's leadership must balance production and protection with the same skill as they balance credits and debits and employee staffing. Over the last 50 years, there have been paradigm shifts in the evolution of safety thinking, and the accident rate has steadily improved as a result. The first shift was technical factors. In the 1950s, accident investigations focused primarily on equipment failures. As aviation technology improved, better, more reliable equipment reduced the number of equipment-related accidents. Think of how much better our jet engines, avionics, and navigation aids have become. With further technological advances, aircraft systems became more reliable and pilots took on a system monitoring role. The downside was, as aviation became more technologically complex, the opportunity for humans to make a mistake increased. Shift number 2 involved human factors. At the same time that their complexity was increasing, new systems were becoming more reliable and fault-tolerant and included warnings and annunciators. As a result, the focus of accident causation shifted from mechanical equipment failures to human factors. As this period progressed, there was a greater realization and emphasis placed on reducing and controlling human error. The current paradigm shift focuses on organizational factors. Over time, through observation and the study of human factors, some in the aviation community began to consider whether there were underlying factors that put pilots and other aviation personnel at risk for making errors. The chief focus became how well does the organization support the employee? Factors include increased globalization of aviation suppliers and services, resource limitations, time and on-time pressures, organizational management, and organizational culture. The aviation industry began to pay more attention to management and began to develop management standards. SMS is a product of this advanced thinking. It applies the concept of management accountability, management involvement, the importance of dealing with the entire system, and the critical steps of managing, controlling, and monitoring safety risk. Safety culture permeates an organization. It runs across all SMS components and must be considered in the discussion of any SMS. But less is said about how these concepts relate to things we can observe, test, or manage. This block, representing the system environment, is where the SMS has the greatest applicability and impact. Within the system and environmental arena is where our production processes reside and where we can manage most effectively. For example, what laws and regulations must we comply with? What are the industry standards and norms? And how do business and market relationships affect our systems? The equipment, tools, facilities, policies, procedures, and training also shape the environment in which frontline employees work. Next is the psychological aspect, which is how people think and feel about safety. National and professional cultures affect how people think, feel, and interact. This affects how employees behave in the operational environment and the values that they hold. The psychological element is arguably one of the most deeply rooted elements because it contains the human thought and decision-making processes. It is one of the hardest to affect through direct action. The third block is the behavioral element of organizational culture. This relates to the way employees act and respond to situations. Behavior can result from several sources, including rules, procedures, direct supervision. However, behavior can also result from more deep-seated values and attitudes. The behavioral element of the culture results in the outputs and performance outcomes of the organization. When standards are set for performance and conduct, the outputs or outcomes can be observed, but we can't manage them as directly as we can the system or environmental aspects. That is, we can buy resources, but we can't really buy behavior. While it is difficult, if not impossible, to manage the psychological and behavioral aspects of the organizational culture, they can be measured to determine how effective the management of the system and environment is working. Sound decision-making, fair practices, management's behavior, and reinforcement of safety-related values can go a long way to change employees' attitudes and performance. Professor James Reason outlined a system he called the informed culture. Now, there are 4 key components: reporting, just, learning, and flexible. SMS is all about informed decision-making, where management and employees understand safety management and share a common safety culture where hazards and risks are acknowledged. Safety culture is the product of individual and group values, attitudes, competencies, and patterns of behavior that determine the commitment to an organization's safety health and safety management. The reporting culture encourages employees to divulge information about all safety hazards that they encounter. Two-way communication is paramount. It also stresses forthright reporting on the part of management. In a just culture, there has to be a level of understanding throughout the organization on what is acceptable and what is unacceptable. Employees are held accountable for deliberate violations of the rules, but encouraged and rewarded for providing essential safety-related information. Just culture is all about fostering trust. A learning culture places emphasis on using information to improve knowledge. It stresses analysis of events, performance, and risk over assessing blame. They learn from their mistakes and communicate safety issues. A flexible culture adapts willingly to changing demands and allows quicker, smoother reactions to out-of-the-ordinary events. All the reporting, analysis, and learning is useless if we're not willing to take action. We've been talking about how important a sound and positive safety culture is to an SMS. So just how do we influence safety culture? There are 7 necessities that require action to foster a sound safety culture. The first 5 necessities are policy expectations that relate to safety policy and a positive safety culture. Senior management commitment. It must be actions, not words. Senior management visibility. If employees cannot see it, it does not exist. Safety accountability and framework. Is organizational leadership held accountable for safety performance in the same manner as on-time performance, aircraft reliability, and pilot performance? Safety policy goals, objectives, standards, and performance. Are they realistic, achievable? Do they even exist? Resource commitment. Do the people with the responsibility and authority have the tools for safety success? The last 2 necessities relate to the safety assurance processes, which facilitate the psychological and safety culture of an organization. Effective employee safety reporting system. Is it confidential, non-punitive, and just? And a safety information system that provides an accessible, efficient way to retrieve safety information. Who wants to be in a reactive organization? Well, not us. Reactive is old school. It's bad, right? We want to be proactive, modern, advanced, maybe even predictive. Out with the old, in with the new. Let's take a look at safety management strategies. If you're reactive, you look at past events. You learn from failures and performance shortfalls. Very often we say we want to be proactive, not reactive, but that is not always realistic. We must be ready to learn from our failures and our shortfalls. Reactive will always be with us so that we can learn. We just don't want to be only reactive. If you are proactive, you look at your current processes with an eye toward what's wrong. This is the primary job of the SMS Safety Assurance function, with its audits, evaluations, employee reporting, and the associated analysis and assessment processes. We shouldn't rest on the fact that we put good processes in place and have hired good people to perform them. We should actively seek to take in information and find out what's really going on. To be predictive, your concerns are things that you haven't done yet. The what-if scenario of new technology, new markets or aircraft, changes in operation, etc. This is the primary domain of the SMS safety risk management process, figuring out what may go wrong in the future and building in the defenses. We won't, however, catch everything, so it's important to have strong proactive safety assurance processes and effective reactive processes to continue learning from the inevitable failures before they get out of control. There is an appropriate place for each of these strategies in the development of an SMS and in operations in the real world. We want to be predictive where we can, build and design to avoid as many hazards as we can. Then we want to take active steps to assure that our systems are working and fix them when they are not.